Hello everyone, and this time we will be having an example on finding the critical points of a given function. Before going to the example, let me review first what are the necessary steps that you should carry out in order for you to find the critical point. So the very first step, or step 1, is find the derivative of the given function. And when I say find the derivative of the given function, the function you should find f prime of x, and you will derive also the function with respect to x and determine if it does not exist, the possibility that the function does not exist, because last time we understood that if a function, if the derivative of the function does not exist, so there is also a possibility that it will produce a critical number, and therefore producing also a critical point. Then step number 2, set the derivative to 0 and solve for the values of x. These values of x will produce critical numbers. And step number 3, after producing critical numbers, substitute those x values, which are the critical numbers, to the original function. Maybe I should write that in words and not in letters only. Substitute x values to the original function and evaluate. And this number here, or this step, will produce critical point. So in summary, there are 3 steps that you need to do in order for you to have the critical point of the given function. The first one, derive the function and derive also the possibility if the derivative does not exist. Step number 2, set the derivative to 0 and solve for x in order for you to have critical numbers. And step number 3, substitute the x values, or the critical numbers, to the original function and evaluate to get the critical point. So we'll have our first example. So our first example number 1, is given by the function f of x equals x cubed minus 3x squared minus 9x plus 15. Plus 15. Now the requirements are the following. The requirements should be find the critical numbers and the critical points. Cn represents critical numbers, Cp represents critical points. So step 1, find the derivative of the given function. What's the derivative of this? This is 3x squared minus 6x minus 9, right? And then, is there any possibility that our function with respect to x will have a derivative that does not exist? Let us examine the domain of the given function. When I say domain of the given function, the allowable x values that we are permitted to substitute for x. In this function, this is a cubic function or a polynomial function because the exponent is 3. And we all know in advanced algebra that any polynomial function, the domain will be all real numbers. So in other words, there is no possibility that our function will have a derivative that does not exist. So in other words, none. So none. So we will continue with step number 2, and step number 2 says we will set our derivative to 0 and solve for x. Okay, so we will set 3x squared minus 6x minus 9 to 0. And how do you find x? Take note, this is x squared, so in other words, we will arrive at two values of x sub 1 and x sub 2. 3 is common in all terms, so I could factor out 3. So I'll be retained with 3 times x squared minus 2x minus 3 is equal to 0. This is algebra. Okay, and I could factor out further this parenthesis or this trinomial to what? X and x, factor of negative 3, that we will add them will produce negative 2. So minus 3 and plus 1. Check that one. Okay, I think that's right. So the first value of x will be x minus 3 equals to 0, x plus 1 is equal to 0, and solve for x. X is positive 3 and x is negative 1. These are the two values of x that we have found after setting the derivative to 0. And what do we call these numbers? We call those numbers as critical numbers. So in other words, this is critical number 1, okay, and this is critical number 2. Step 3, final step to find the critical point, is to substitute the critical numbers to the original. Where's the original function? Okay, not the derivative function. This is our original function. We will substitute here the values that we have obtained, and those values are 3 and negative 1, and we will evaluate. So I will start with x is equal to 3. So I will find f of 3, that will be equal to 3 cubed. I will substitute 3 here in all x's. Okay, minus 3 times 3 squared minus 9 times 3 plus 15, and then evaluate. Okay, please pause the video if you would like to, and then evaluate. And I have done this problem, so I'm very sure that if x is 3, I would get here positive 12. So the first critical point is equal to 3, 12. Okay, another one, we will evaluate here at negative 1. When we say evaluate at negative 1, we will substitute negative 1 to all x. So this will become negative 1 cubed, this one, the original function. I will change x to negative 1, all x's. 3 times negative 1 squared minus 9 times negative 1 plus 15. Same as before, you may pause the video and evaluate these different numbers from left to right. And I have done this one, and my answer here is 20. Please double check. Okay, so in other words, my second critical point here is equal to negative 1 and 20. Okay, so far so good. That will be our first example. So in the given problem, if we are required to find the critical numbers, here are the critical numbers: 3 and negative 1. Okay, the second requirement are the critical points. Here are the critical points: 3, 12, and negative 1, 20. Okay, if for example somebody would request you to sketch that one in a graph, then you will locate the critical numbers and the critical point, and we will sketch the graph. I think that will be on the first derivative test, in which we will sketch the graph of this function. Thank you very much. I hope this first example will help, and see you soon in the next video.